Okay, so we are going to discuss definite integration, and specifically first we are going to revise and recall what properties we discussed in yesterday's class. Then thereafter we are going to discuss and solve PYQs of this chapter. So as you know about this quote, practice makes a man good. Why being perfect always? Perfectionism, I guess, somewhat creates kind of inferiority complex or a obsession. Anyways, uh, just you have to be good, and if you will be good in each and every aspect of your life, whichever you choose, then I guess your life will be perfect. So yeah, just keep on practicing and improving. Okay. So these are the properties. Property number A, we discussed it earlier. So, this is change of sign when we change the limits. Breaking of limit when C is lying in between A and B. Tanish, do you have any doubts from previous classes?
No, sir.
Okay. The third property, odd function and even function. And fourth property, where we were changing the variable to A plus B minus X, upper limit plus lower limit minus of the given variable. And fifth property, where we wrote down this property. Let's discuss this. We didn't discuss this in detail yesterday. So this is the function on which definite integration is taking place. Given that 2a is the period, 2a is the period of the function, or like 2a minus x is f of x. First, if we just break down it from 0 to a and a to 0, sorry, uh, from 0 to a and a to 2a, then we can further write this as, let me explain. So what we are doing here, that we are replacing 2a plus 0 becomes 2a minus of x into dx, right? 0 to a. We can rewrite the given function as this a, yes, using the above property only. Okay. So in this case, if f of 2a minus x is f of x, so if we will just substitute it here, it will become double of f of x, limit from 0 to a. And if f of 2a minus x is equals to minus of f of x, then it will be 0. Is this property clear? Is this property clear? Fifth one?
Yes, sir.
Here then. Considering that a is the period of the function, period is what on which, after which the domain starts repeating the range. Like the function's value starts coming as equal and it have nullified effect. Like for trigonometric function, 2 pi can be said as a common period for all the trigonometric functions, right? Or pi. So a is just like that. A will just get neglected if it comes in form of integers multiples. So here, if there is a function whose definite integration is happening from 0 to n of a, then n can be simply written in front of in the multiple and to the multiple of a definite integration of function from 0 to. Is this property clear?
Yes, sir.
Keep on responding. Seventh property is simple, that there are three functions, e of x, f of x, g of x. If they are in this condition for a and b, for x belonging between a and b, including a and b as well, then the definite integration of them on the same limit will be in the same condition. will be in the same given condition. Is this clear? These are just functions and whose definite integration will follow the same inequality condition. Now it's clear. Any doubts?
No, sir.
Next function, next property is a very basic one. That if we are taking the modulus of any definite integration, can be represented as, sorry, it would be less than or equal to, yes, it would be less than or equal to the definite integration of modulus of function, and then after that, if we are integrating it. Earlier, we were doing first definite integration, then we were taking the modulus. Okay, and in this we have just taken the modulus on the function. Is this property clear? Any doubts?
So,
Yes.
Ninth property says if the function is positive on A and B, then definite integration on A and B would also be positive. Property clear? Is this clear?
Yes, sir.
Next property and last property says that if M and M is the global minima and M is the global maxima of function is in A, B, okay, then like, this is the point on which maximum occurs, and this is the point on which minima occurs. So they both lies in E, B, then M of P minus A and M of B minus A. The function, the definite integration, the area under the curve in between A and B would be in between these two, like the minima and maxima. Is this clear?
Yes, sir.
So moving ahead, let's first discuss about greatest integer function. Anywhere aware about this function?
No, sir.
So this is represented by bigger brackets, square brackets, and like this. And if there is any value between, let's talk about positive x. Okay, so if there is any value between 0 to 1, including 1, including 0, sorry, excluding 1, and including 0, the value of the function would be, or let's write it as this only, the value of function would be 0 only. Okay, and for all values from 1 included to 2 excluded, the value of the function would be 1. It means to say that it will have always the greatest integer function. Like any number, if we understand like 2.3, so it can be written as 2 plus 0.3. So any number can be represented in its greatest integer function plus its decimal value, whatever the decimal value it have. So greatest integer function will always have an integer. Okay. So coming back here, for all values, let's take one example. For 0, it will be 0. I'll write x here and modulus of x here. For 0, it will be 0. For 0.5, it will be again 0. For 0.999, it will be 0. But for 1, it would be 1. For 1.1, it would be again 1. For 1.9999, it will also be 1. For 2, it will be 2 only. So this is about positive numbers. You get the gist, you got the point, you got the hang of it, that you are just taking the integer out of the positive number, right? Is this clear? for positive x?
Yes, sir.
Yeah. So let's discuss about negative of x. For 0, the for x equals to 0, the function is going to give 0 only. For 0.1, it will give minus of 1. It is always giving the lesser value of the integer. The next slide also we have considered that 2.3 was a bigger number than 2, but 2 is a integer which is in this. So like if this is the number line 5, 4, 3, 3, 2, 1, 0, minus 1, minus 2, so on, so on. So if greatest integer function, any number, like if there is any number, let us say 2.3 only, like it would be somewhat here. It would be somewhat here 2.3. But it is only going to consider whatever integer which was uh, like what should I say? पीछे को क्या बोलते हैं? Whatever integer was backward this point. So what integer was there? 2. And for let us say minus of 99, minus of like say for minus 0.5, which would be here somewhat. So it will only consider the integer which is backwards this arrow, which will be minus 1. So in this way you can understand, right? Is that clear?
Yes, sir.
So I will answer what will be its value. Minus 2.3. Given that this is the greatest integer function. Anyone? Okay, tell me what will be the greatest integer value of 2.3? Please respond. No problem if you'll give any wrong answer. You'll learn only. If you won't give any wrong answer, then I'll just move on and the next topic will be discussed and this topic will remain unclear to you.
2.
Yes, for this is 2. And for this, what will be its greatest integer function? Minus of 2.3?
Minus 2.
No. For minus of 2.3, it would be somewhat here on this point, or not here, right?
Okay.
Minus 2.3 would be here. So if an arrow will be drawn to minus 2.3 from the left side, and the which integer will be there behind minus 2?
Minus
Minus
3.
of 3. Yes, so it is minus 3. You can also remember this graph. You can also remember this graph. This graph is also known as a lollipop graph, or various names are given, where this bold and dotted line is represents that this number is included, and this whole represents that one is excluded. Okay, so this is how you can also remember it. There's another method which I just came to know is this, that you can draw an arrow from the left side. You can see which number is there. And you will just come to understand it if you practice enough. Let's practice. I'll write x here and the output of that function will be told by you. I won't speak. I'm just going to write numbers here. So 2.99. Respond. Come on, everyone. Unmute yourself and speak. What will be the greatest integer function of 2.99?
2.
Yes, nice. Minus of 2.99.
3.
Minus 3.
Oh, minus 3.
2.5.
2.
Yes. 1.5. 1.5.
1.
1. Right. 0.5.
0.
Yes. Minus of 0.001.
Minus 1.
Right. So you have got the hang. It works like this only. Okay.
Mm.
Any doubts, anyone?
No, sir.
Okay. So let's discuss this question. So now we know there are two functions in multiple, so we can use isolate. And here for choosing our first function, the differentiation will happen like this. First function, second function is the integration, then first function derivative, then second function is differentiation, then wholes differentiation. So here to choose the first function, I will use the isolate part. So here is no inverse trigonometric function. There is no logarithm. There is no algebraic. There is trigonometric. So this becomes our first function. So first function into integration of second and minus of integration into differentiation of sine of x. Differentiation of sine of x is cos of x. A differentiation of sine of x is cos of x plus or minus. Come on, tell me the sign of differentiation of sine of x, whether it will be plus cos x or minus cos x. Yes, Tanish, Rishi, Yazini.
Cos X.
Cos x
Okay, plus or minus?
plus.
Yes, plus. So integration of cos of x into integration of e of x dx and wholes integration again. So this is, let's consider this integration and let's call this indefinite integration as integration. Okay, we will apply its limit later. Integration of e of x dx is simply e of x. So sine of x into e of x minus integration of cos x into ex dx. Now again we have to use the first and second function use here, roll here. So this will be your first function, this will be your second function. So sine of x into e of x minus first function into integration of e of x dx is simply e of x. So write this as this only, minus of integration of what is the differentiation of cos of x? Please unmute yourself and speak. What is the differentiation of cos of x? It is sine of x, which is in negative sign. So negative will cancel it and make it as positive. So earlier we were finding about the integration of e of x sin x, which we called as I, right? Yes, are you with me?
Yes, sir.
So again, we have another I in the equation. So let's substitute it for I only. So now further simplifying, this has become minus of e of x cos x minus of I is equals to I. So let's bring that I to the right hand side and make the right hand side as 2 of I. Clear? So now taking e of x is common, sin x minus cos x is equals divided by 2 is equals to integration. Now there was a limit on our integration. So applying the limit here also. So pi 0. So e raised to power pi and sine of pi. Now please tell me what is the value of sine pi and cos pi. On 2 minus e raised to power 0 sine of 0 minus cos of 0 upon 2. This is I after getting limit 0 to pi. Please tell me the value of sine pi and cos pi.
-1.
What is the value of cos pi? That is -1. The value of sine pi is 0. Yeah.
Oh.
So this minus and this minus will cancel each other, and this will become e pi divided by 2. And sine 0 is 0, cos 0 is 1, so -1 will remain also here. E raised to power 0 will also become 1. So minus minus will again make it positive, and this is e pi plus 1 by 2. So the answer A is correct. Is this question clear? What we did, we simply first solved for the indefinite integration here, and while solving there was a loop here. So we substituted that with the integer I, and somehow we were able to get that I to the right hand side, and fortunately they didn't cancel each other, or mathematically we can say unfortunately. Then we solved the integration. Thereafter we applied the limits. We solved the answer. Okay, clear?
Yes, sir.
Yes. I request everyone to respond, please. Okay, so next question. Here also we can see there are two functions using the same formula. Now this is an algebraic function. This is a logarithm function. So L comes first. So ln x would be our first function, integration of x dx. And we will apply the limits later on. Minus integration of ln x into integration of x dx and whole integration. This is our I, as we call this is I. So ln x integration of x would be x squared by 2 divided by x squared into ln x into dx, and let's bring the half. So this has become x squared ln x minus 2 of I integration of x squared into ln x into dx. Now again we will have to apply the formula of isolate here whether we have this product to integrate. So this is algebraic, this is logarithm function, this will be considered as first, this will be considered as second function. So x squared ln x minus integration, sorry, write it in square bracket. So first function as it is, integration of second. So integration of this will be x cubed by 3 minus integration of first function's derivative. So wait, we done a mistake. Here we had to take the derivative of this. Have you got what I have done the mistake? What mistake did I did? Actually, if we see Eilert's formula, there is first function integration of second minus, then there is we had to multiply the derivative of the first function to the integral of second function. Thereafter, we have to take once again the integration of whatever there is. So so the differentiation of ln x is 1 by x. Integration of x dx is x square by x square by 2 into again integration. So it is x square by 2 ln of x minus half x cuts x, and again half integration of x dx equals to integration x square by 2 ln of x minus 1 by 4 to integration of, sorry, let me write neatly, 1 by 4 into x square by 2 again. This is I, and now we have x square by 2 ln of x minus x square by 8. This is our integration. Now let's apply value limits from e to 1, e to 1. So first putting the upper limit ln of e minus e square by 8, and then subtracting it, putting 1 by 2 ln of 1. Now please tell me what is logarithm of 1. This is the answer. So logarithm is what? Logarithm to the base e to e. It is 1. Logarithm of e to the base 1 is 0. So have you read, do you know about logarithm, or should I include that chapter in between our scheduled syllabus so that we can go ahead with strong basics?
No, sir, I don't know about logarithm actually.
Okay, good. Good that you told. And what about others? Tanish, Rishi? Yes, Tanish, Rishi, are you sleeping? I
No,
guess.
sir.
Okay, so do you know about logarithm? Logarithms.
No idea, sir.
Okay, so we'll cover that. No problem. We'll include that first in our planned syllabus. So logarithm of 1 is 0. So this has become 0. And this has become 1. So simply a square by 2 minus e square by 8 minus of minus 1 by 8. Now this becomes, after taking LCM as 8 here, so 4 of e square minus e square, then plus 1. So this becomes 3 square plus 1, which is not equating to any of the given options. It looks like that we have made some mistake in the calculation. Let's find out what. So x square by 2 ln x minus x square by 8. Let's check. No, yes, there is a solution given. So e square by 2 minus 0. Okay, अच्छा. Minus half of half into x square. There we have done some mistake, I guess. Let's check from here. So our first function was logarithm of x, integration of x dx minus the differentiation of this and this particularly. Integration of x is x squared by 2 ln of logarithm of x minus minus integration. What is this half for? For nothing. We have already written 2 inside the differentiation. So what's its use? Okay, so this is one mistake. We have mistakenly written half. Let's find out, are there any other mistakes also? Okay, so we have done small calculation mistake, which is it has become a blunder now because we have wasted our time. Thank God it's not an exam. Yeah. So continuing x here half, and then it has become 1 by 4, so it is 1 by 4. Now substituting e square by 2 ln of e, which is 1, minus e square by 4. Further, then ln of 1 has become 1, so 1 by 4. Now taking 4 as LCM, 2 e square minus of e square plus 1. It's become e square plus 1 by 4. So B is the answer. Let's check. Yes, B is the answer. So is this clear, everyone?
Yes,
The
sir.
concept of question? Yes. So first what we are doing is we are simply solving for the integration. Thereafter we are applying limits. Yes, now here as you can see, this is a greatest integer functions. So the only so let's first write our question. So 0 to root 2. Root 2 is up around 1.41, right? So let's break this function in limits from 0 to 1. X square into dx. And then from further 1 to square root of 2. X square into d of x. Now, for all values less than 1, like let's consider 3 by 4, its square would be what, 9 by 16? Value would be somewhat around 0.5, so it would be 0 only. So that's why we are breaking this function. We have broke this function. Now for all okay, so its value is coming out as 1 only, because even the square of 0.99, let's find out what is 0.99 square. Where are the tools? Where is the calculator? Anyway, even 0.99 square will be 0.98 only. Okay, 0.9801. So the moral of the story is its greatest integer function is always going to be 0. 0 dx integration of 0 plus for all values from 1 to 1.41, their uh, their value will always be 1 here. So 1 dx 1 root 2. Are you able to understand why have I written 0 and 1 here? Because for all values from 0 to 0.99, the greatest integer function is just going to become 0. And for all values from 1 to square root of 2, the greatest integer function is going to give 1 as the output. So have you understand why have I written so?
Yes, sir.
So integration of dx is what? Simply x square root of 2, 1, upper limit minus lower limit, and which is our answer. Is this question clear?
Yes, sir.
Everyone,
Yes, sir.
please keep responding. Yes, here you can also see the same method used. So this is a question. Can you recall some property after seeing this question? Anyone, please, if you are able to recall some property, please unmute yourself and tell me what's that. That famous property, this one. Anyone? Now, is anyone able to recall?
No, sir.
Okay. So for odd functions, it becomes 2 into integration of f of x dx from 0 to a. For even functions, it becomes 0. Okay.
Yes, sir.
Yeah. I've written it wrong. Not intentionally, of course, by mistake. For even functions, this is for odd functions, because odd functions, when we solve it for this, so we'll cancel each other and we'll write it as f of x minus f of x. So then f of x, it will, or for odd function, f of minus x will become minus of f of x. That's why it is cancelling, and that's why it is become 0. Anyways, let's move on and discuss about the solution of this question. So going ahead, let's discuss about the function. The function is sine of x minus cos of x. For negative of minus x, sine of minus x minus cos of minus x. So here, this is a trigonometric plane. So this is 0 degrees or 2 pi degrees. This is 90 degree or pi by 2. This axis represents 180 degrees or pi. This represents 270 degrees or 3 pi by 2. So in this quadrant from angle 0 to 90, all trigonometric functions are positive. Okay. And in this, all sine and cosec functions are positive. In this, tangent and cotangent functions are positive. In this, cosine and secant functions are positive. So you can remember them using a trick, saying after school to college. Simply A denoting all trigonometric formulas, S denoting sine, T denoting tangent, C denoting cos. Okay, so you can just remember them. This is for first quadrant, second quadrant, third quadrant, and fourth quadrant. So here sine of minus x means we are going minus. So from 0, if we start here to the, like, and the angle is always calculated in anti-clockwise direction. If we will go clockwise direction, then the angle would be considered as negative. So if there is a negative sign, so the angle is existing in the fourth quadrant. For fourth quadrant, sign is negative. So it is written as, so it will be written as minus of sine x. And for cosine, it is positive. The fourth quadrant, the fourth quadrant is positive. So it will remain as this only. So for f of minus x, our function as f of minus x has become, say, sine of x plus cos of x. Let me see the function again. The solution, sine of x minus tan of x, if there is a negative sign. Okay, problem is there. I am idiot. No problem. I did a mistake. There's no cos x here, there is tan x. But this is correct. Like the what concept I have told is correct. Sine of x minus of tan of x. For f of minus x, this will become simply minus sine x. And for tangent minus of x, this will also be negative. This will become positive. So now after taking negative sign common, the remaining expression can be written as f of x. So hence it proves that this given function is an odd function. This minus minus will make it as tan, positive tan of x, f of minus of x, taking minus common, sine of x, sine of x minus tan of x. My laptop stops responding sometimes. So this given expression can be written as f of x. This proves that the given function is an odd function. And hence, for odd function, this property says that the definite integrations value would be 0. So option number C is the correct answer. Is this question clear to everyone?
Yes, sir.
Yeah, great. Any doubts, anyone?
No, sir.
Great. So let's discuss next question. So here the question is given like this. So let's solve for the first integration. It will be x raised to 4 by 4, limit from b to a. This is given as 0. And x cubed by 3, limit b to a, it's given as 2 by 3. So taking 1 by 4 as common, b4 minus a4 is 0. And here b cube minus a cube divided by 3 is given as 2 by 3. 3 cancels 3, here 4 cancels, and b raised by 4 becomes a raised by 4, and b cube minus a cube becomes 2. So if we just simplify it, we can write it as a is equal to plus minus of b. Understood or not? If not, let's solve this further. 0 is a4 minus b4. 0 can be rewritten as a square minus b square into a square plus b square. Okay, so here you can simply see a can be b, a square can be b, so we can write a can be equal to b, or a can be equals to minus of b. That is for sure. A can be plus, a can be written as plus minus b. Now is that clear, everyone?
Yes.
Is that clear?
Yes, sir.
Yes. So let's focus on solving this. So b cube minus a cube is 2. Okay, now we can substitute. Now we can use our options also, because we have to utilize whatever resources we have. So if we consider A equals to B as per our assumption, so B minus A, it should be 0, but it is not satisfying our this condition. So it is evident now that B cannot be equal to 0. Yes. Yes, are you able to understand it? Because only this is our first result. This is the result from our first condition. This is the and this is the result from our given second condition. Second condition. This was so we are verifying our result from the first. So if we will put A is equals to B, condition number 2 fails. So that's why we are saying that A cannot be on footing. So A cannot be equals to B. So A has to be minus of B. That is for sure. Right? What is the meaning of this result? A can be either plus B or A can be minus of B. For A is equals to plus B, if we are putting A is equals to plus B, so 0 cannot be equal to 2, right? Because let's say B minus B cube becomes 2. So 0 is equals to 2, which is very much wrong, right? So that's why our this condition is not satisfying our condition number 2, which is given to us. That's why we can say that A must be, then the remaining situation should stay true. A should be minus of B. Now let's, is that clear? Are you with me? Any doubts?
Yes, sir. Clear.
Yeah. So A has to be minus B, and we had the equation BQ minus 2B BQ minus A cube is equals to 2. So let's substitute for A is equals to minus of B. B cube minus A is minus of Q. So B cube minus sign will come out because minus 1 when it is multiplied 3 times, minus 1, this will become plus 1 into minus 1. This will become minus of 1. So that's why this minus sign will cancel each other and it will become like this. So 2B cube equals to 2. 2 cancels each other. B will become 1. So if B is 1, A will be minus of 1. So from the options, option number A is correct. Is this question clear?
Yes, sir.
Yeah, great. Any doubts?
No, sir.
Let's move on to the next question. Now in this question, the given form is a little complex for us to like substitute. So we have to use a property. The property is f of x when it is like this. So we can just simply change the variable to a plus b minus of x. And why we are doing so? Because there is a higher exponent to a polynomial which is more complex. If somehow we can make it simpler, then our work will be done. So in this case, 0 to 1, f of x, we can write f of 1 plus 0 minus x, right? As per the property. So integration of 0 to 1 of f of minus of x. So integration of 0 to 1, x becomes minus of x, and here 1 of minus of 1 plus x. Clear? However, written so because 1 minus of 1 minus x will become 1 minus 1 minus minus positive, and 1 will cancel each other, and hence integration of 1 minus x into x raised to power 9 into dx 0 to 1. Clear?
Yes, sir.
Now see the magic. So now we have 0 to 1, 1 minus of x raised to x raised to power 9 dx. Now let's multiply x raised to power 9 inside the bracket. So x raised to power 9 minus of x raised to power 10 into dx. So now this is very easy to integrate. Okay, integrating this. So 9, 10 by 11 by 11 and limit 1 to 0. Clear?
Yes, sir.
So on putting x is equals to 1 by 10 minus 1 by 11, subtracting from while putting 0, 0 minus 0 is simply 0. So 1 by 10 upon 1 by 11, let's taking else on taking LCM. So 11 minus 10, simply 1 by 110. Matching options, option number A is correct. Is this question clear, everyone?
Yes, sir.
So we have just smartly used this trick to change the variable. Okay, so this is another question in which there is a greatest integer function given. So we can simply write them with each other, right? So now we have to understand one thing, that whenever for any value of x, let's take some examples. Let's take some examples. Okay. For x is equals to 2.3. What is greatest integer function? Please unmute yourself and speak. Let me take some other number. Yes, now. Please, no problem if you give a wrong answers. Yes, anyone? What is the greatest integer function of 2.9?
2, sir.
Good. And what is the greatest integer function of minus 2.9?
-3.
Very good. Let's take, if you take any number like 1.0.23, its greatest integer function will be 108. And if we will take just the negative of it, so it will just become minus of 109. Okay, because minus of 109 comes to the left of minus of 108, whereas plus of 108 comes to the left of 109. So if we are taking arrow like in this direction, then 108 will be considered. If we are taking arrow in this direction, then 109 will be considered, right? Yes. So now on observation, for any x, if we take greatest integer function, considering that x is a positive integer, so it will be somewhat like, let's take an example. Let x be 2 here. Let x be 2 here. So for 2 it will be simply, so let x be 2.3. For 2.3, the greatest integer function will be here 2, plus for minus of x, for minus of 2.3, the greatest integer function will be minus of 3. So this will come out as -1 every time. For all x, this sum is going to become going to equal as -1. If you simply add these two, the sum is -1. If you simply add these two, the sum is -1. For all x and minus of x, if their greatest integer function are getting summed, added, their sum is going to be equal as -1. Is this claim, is this concept clear to you, everyone? Any doubts
Yes.
about this? Yes. So now we have known that this particular sum is always going to be minus of 1. So just replace the function in simpler method, simpler manner. Now, the integration of minus of 1 is simply, minus can be taken common. Integration of dx is x, b of a. Now, -1 into b upper limit minus lower limit, minus sign when get multiplied from a minus b, which is the correct answer. Now, is this clear to you, everyone?
Yes, sir.
Yes, this question is very easy, but provided that you have to know the basic concept, you have to understand greatest integer function in a deep, profound manner. Yes, so that's all for today. Any doubts, anyone?
No, sir.
If no doubts, I would like you to remember all the formulas and keep on asking questions. If you have any doubt, keep on practicing. If you feel any problem, you may type it at any time in the WhatsApp group of us. And please keep on studying and keep giving time to the mathematics, the notes. Keep making notes. Keep on practicing previous year questions. Or if time not allows you, then please keep on practicing your NCRT at least. Okay. And any reviews or feedback for me?
No, sir. It was good. Today's class was easy.
Okay. So let's shall we conclude today's session?
Yes, sir.
Thank you, everyone. Good night. Jai Hind.
Thank you.